Okay, so we're going to cover results today. So results is the most important part of the paper. If you don't have any results, then you don't have anything to showcase from your work. And like when I say the most important part of the paper, when I review a paper, I usually look at the discussion first. But the results is what help you get your way to discussions. So, and sorry, Joyce, I forgot to ask you. So you're just you're also powering through the paper and writing the journal paper with Sophia, right?
Yes, yeah.
Okay, perfect. And then you have one new teammate join the team in the summer.
Yeah, Alvaro.
Okay, perfect. Okay. So in terms of the results, the figures, so in terms of the results, what determines the results is the figures, the graphs, the tables that showcase your results. So obviously, when you're doing your results, you should keep a lab notebook and keep track of the results that are going on. From your weekly meetings, you should also have, your lab notebook and stuff. I'm trying to see if I have a slide of um, the slide of the results. No, so I think I show you the results in Research 101. Oh, here it is. Right. So this is like your lab notebook of your experimental results. This is not the most complicated projects we've done. This is from one of the smaller projects that we've done. And I'm just gonna put it into the results section. Yeah, but you can see that, like we usually have like some models, some metrics, or some conditions, and we have some aberrations. These are all the different adapter methods that we did. And then here are all the different what do you call it? Settings, right? Like we were doing aberration, we were doing parameter tuning on the reduction factors. So we did all of this for a rebuttal period of like 3 days, which was pretty crazy. Yeah. Okay. So what is the purpose of a result section, Dylan?
So the results section of the paper, in short, should be the gathering of whatever your methodologies brings. Essentially, it's the natural outcome of what your methodologies lead to when you're gathering data for a specific purpose, different types. Then your
Yeah.
results will naturally be what happens as a result of that. Yeah.
That is very good. So that is what happens in research and in scientific inquiry. In science, that's what happens. Like you're observing stuff, you're collecting data to sort of, you have a research question and you're trying to decide what it is you're trying to observe and you're collecting data. I think one of the key things in the paper is that your results proves what your research question and what you're trying to say, like, your concepts and things like that. So,
Mhm.
so you want to organize. So for your results, you want to organize from the most important result to the least important results. And a lot of times in our papers, because they're very compressed and short, a lot of the results end up being put in the appendix. So we really want to, but the most important result is the one that answers your research question. We'll also talk about some like writing signals to help you write, important writing principles, common problems of the results. These are benchmarking, which we don't need to worry about as much. Yeah, yeah. Um, so sometimes it's called results and discussions. So in computer science, often results and discussions are combined together. In biology or in different fields, depending on the conference venue you're submitting to, those might be separated out to two different ones. Hi, En-Shiun, we're just talking about results. We just started, but results, we have like a spreadsheet and notebook like this, tracking our results. Yeah, so we combine results. So in computer science, we combine results and discussions. But basically, it's like, the results is your benchmarking, right? Like, how do you evaluate and benchmark what you're doing? And then analysis, and then discussion is just an analysis of those numbers, right? Like, what have you found and what is the most important? Yeah, so ideally, you want to, you know, present the most relevant results. You might have tons of results, and some of them don't, and some of them are irrelevant, right? They have nothing to do with what your research question is, or some of them don't answer your research question, or like, there's lots of different things. So you want to stick to the most relevant ones, and then you also want to stick to the most important, like the most impactful ones. Some of the results might actually not support your hypothesis, and you probably want to like talk about those ones last or later. Yeah. So you want to interpret your results for your readers and analyze the meanings, and that's the important discussion part, right? You want to say like you can't just throw out a bunch of numbers. You have to say, we did this. Here's these numbers, and then here's what it means. And make sure you present the statistics, truthfully. Yeah, so you want to put the one that answered the research question at the beginning. You can do most chronologically or most important to least important. I always say most important to least important. I think that's the best. And the way you can tell if it's most important to least important is most of my papers, it'll have in the introduction the contributions, right? Contribution 1, contribution 2, contribution 3. So then your results and your discussion needs to match contribution 1, contribution 2, contribution 3, so that it's like a nice parallel. I'm a very organized writer. Yeah, and then you want to signal and emphasize your results, but subordinate secondary results, right? Subordinate meaning like just bring down some of the results are not as convincing, or like, again, we always go back to this idea, right? Like you want your one central most important results. If you have 10 results like this, it's very confusing. You want to sort of present it in an organized way. But, you're just putting things together. So for now, just throw everything. Just throw all your results on your page, Vivian. Throw everything on a page. Yeah. And then the way you write your results, the Notion, because you need to write results for your thesis, you want to talk about, you need these 4 things in every results paragraph. You need to say why you're doing something. So the purpose and the background. I need to see this first, like the why. Students, ChatGPT or like, LLMs like to put this at the end as like a empty hedging sentence. Don't do that. Experimental approaches is like what you did, right? So why you're doing something, the steps you did, the numbers you got, which are the results, and then the interpretation of those. Like, what do those results mean, right? Like, don't just show me numbers. You can say like, because this model is the biggest and it's an open model with parameters, then we found that, open parameters has the best results. Well, you can say like, African countries has the most marginalized results, right? Like you need to look at the numbers and tell me what it means. Yeah, so we break it down into 1, 2, 3, 4 sections. So why you're doing something, what you did, the numbers, and then interpretation. And then you can just play mad gab with these, or like just take these phrases. And then I've always written it with these phrases, and reviewers really like it. It really makes things clear. And once I found these phrases, I don't try to write creatively anymore. My English skills are not that good. As a computer scientist, my English skills are, and also as an immigrant, my English skills are not that good. So I just use these structures. Important thing about writing is you need to keep it simple and precise, which is why I hate language models and the text they generate. They're always not precise and not simple. Avoid jargons, right? So use did not, could not, fail to. Don't like, again, the hedging words like clearly, obviously, maybe, or a lot. Significant means statistically significant in quantitative. So I had a collaborator that likes to use like significant without showing that it's statistical. So I had to like fix all of that. You can say like substantially, markedly, like these are called quantitative words versus qualitative words versus quantitative. Like don't say a lot, right? Or very much. Like, like obviously try to say statistical significance by I don't know, 3.65 plus minus 1.04 standard deviation, right? For past tense for results, present tense for descriptive papers, You use present tense if the statement is true, right? So African languages always perform worse. Well, Chinese dialects always perform worst. Those are valid present tense sentences. So your findings, your interpretation and findings can be present tense, but we ran Lemma and Gemini on, I don't know, like QLoRa, like that is the experimental approach. Um, some problems of the result section, you have missing like if you're missing the purpose, the approach, the results and interpretation, you include irrelevant info, you have too much details, but too much details is okay for now. You can always move it into the appendix. Like I said, just write. Writing too much is okay right now. And then discussion in separate sections. And then here are some questions to guide you. Problems, questions, hypothesis. Like what did you learn? What are your results saying? What hypothesis or research question did you answer? Did you get the results you expected? Were there anomalies or anything unexpected? How does your result compare to these findings? And what will reviewers say? So, En-Shiun, I feel like you're ready with your results. So, can you tell me a little bit about how your results are doing?
So far the results are basically like what we expected. I guess like, in terms of like since our project is about using a avatar and voice to
Mhm,
help with LLM interactions, will be better than like a solely text-based LLM.
mhm.
Um,
That's great. Yeah,
and
and what does your
basically,
number say?
I believe I was thinking it was like 67% or 70% of the people prefer to use our chatbot compared to like
Oh,
regular
wait,
LMs. But I have to
67,
get
isn't that one third? Is it exactly one third? Like, how many people did you test?
it's I'm trying to estimate it, but I don't have the stats with me right now.
Okay, that's
But it's
okay.
like it's in the high 60s and mid 70s or something around
Okay,
there,
good, good, good.
from what I
Okay,
remember.
all right. Okay, that's good. And did you do the lab to market and apply for Brilliant Catalyst?
I sent you the I sent the application for the link that you sent to me. And
Mhm.
then the Brilliant Callus, I think I'm still in, need to do that. But I'll get that done
Okay.
today.
Okay, that's great.
Yeah.
All of this can go in your resume. Okay,
Okay.
great. Vivian, tell me more about your results.
Um, so so my result is only partly confirmed right now, but
That's good.
um
That's perfect.
yeah,
Hmm.
but so low coverage groups, language groups are basically have the it's difficult for the baselines like KN and soft impute, but for my approach,
Hmm.
the data for the low coverage language are high, are they
That's interesting.
outperform the baseline. So
How many
but
languages did you cover?
I covered for like um about 7,000 samples in my
Okay.
benchmarks.
No, 7,000 languages?
No, no, it's not 7,000 language, but 7,000 samples. They're like generating from the language, but I don't have the specific language counts in mind because I'm sampling for from the missing features and language pairs, so they're not
Oh, wait, so
just language.
you're doing imputation task.
Yeah.
Are you only doing imputation? Are you doing any benchmarking?
Yes, I'm also doing benchmark and imputation.
How is it different from the two paper they just submitted to AACL and LREC?
Which
Because they
papers?
the one they just presented last 2 weeks ago at EACL.
Oh, yeah. Because we're using
different.
they're using they're using other methods. So they're using the grammar book, but I'm using the knowledge graph and RAG, and
Oh, okay, okay, okay.
so basically it's not the same methods and on the same data set. So
Yeah, hey Vivian, you should really write it up and submit it. Do you think you can have a paper submitted to EMNLP ARR? It's
I
May
think
25th.
yeah, I'm working to it. So I'm
You
not
think?
sure if I can get it done before that, but I'm still grinding to it.
Okay, because if we don't make it for EMNLP, the next deadline is in the fall,
Yeah.
which is
So
not great. Yeah,
yeah.
it's very soon. Yeah. Okay, you should stay and we should find a project for you in the
Okay.
summer, okay? So that you
Yeah.
can I'm very impressed. But at the same time, if you slack off, because I have students who do really well, and then they do nothing for the second project and it gets worse, and then I'm worried. Okay.
Because I want to focus on my project for now, but after, like, for example, after the deadline, I can do more in the
Yeah,
other
yeah.
project.
Okay, so
Yeah.
something that starts in June. Okay, that makes sense.
Yeah.
Okay, we can talk about it. You're right. I appreciate you knowing how to manage your time. I think that's a big a big thing is about how to manage your time and not
Yeah.
overcommitting. Okay, all right. So that's great. I'm very excited about your project. Very interesting. Okay. So, this is a quick guide to benchmarking. Usually, I think that doesn't usually, I guess it could work for everyone. I took it from ETH Zurich, which is actually one of the top institutions in the world for research. And they're actually better than University of Toronto in Canada, in my opinion. So it's very, very important. Yeah. So for benchmarking, I'm going to tell you how. And you want to measure runtime. You want to present your results in writing, and you want to present your results in talking. And there's some examples. Yeah, so the first part is verifying your code. So the Notion, yours is more applied project, so you're okay. But for sure, Vivian, make sure your code is correct. If there's any numbers, so I was actually telling Jahanvi this, if any numbers seem a little bit off, make sure you check it. Like I remember she's running a bunch of models, and I remember her IA 101 model has like really like zeros. I was like, oh, Cohere's not gonna like that. I'm meeting Cohere next week, so yeah. Make sure you measure your runtime and compare against the best available code. So for you, if you're comparing model, make sure you compare against like best, or in this case, baseline code that's available. Yeah, so to Notion, your baseline is, text ChatGPT. And Vivian, your baseline is probably like the previous code from York and Adia. Make sure it's compiled, use, the set when you are clocking the time, make sure you use the same timing method to compare to track the time. Be fair, and also for sanity check, compare the published results. So I don't know how many of you guys did research 101, but the first step was to do reproducibility, which is do the baseline and then compare against the previous baseline or the previous baseline, which is usually the published results, right? Did you compare your baseline, Vivian, to the Uriel Plus publication they just did in March?
I think it's not, it can't be like directly compared. So we'll
Okay.
do a methodology comparison, but not like,
Okay.
yeah.
Okay. All right. And then in terms of measuring the runtime performance, you have to, you want, usually we use flops, so number of floating points, operations per second, and then compare it to peak performance. Have you seen these before, Dylan?
I don't think I've used this or seen the terminology of flops before in particular,
Okay.
but
Okay.
yeah.
Okay. So we want to figure out the peak performance can be difficult. So, you want to count statistically, like using cost analysis, or dynamically, which is tools that counts or replace ops by counters through macros. So, there's different ways of counting how things work. Different algorithms may have different op counting, so flop is not always the best runtime. So this is for like algorithm runtime. I think none of you does like pure algorithmic stuff. That's like A-star conference. Like to get into NeurIPS and iClear, like this is the kind of work you gotta do. Okay. So how to measure runtime? You can use C-clock, you can use get time of day, you can do performance counter, just make sure you get the time on the clock and then you measure the difference. You have to check whether you have a full cache or a cold cache because sometimes your cache will empty and that takes time. Measure repetitions, and then make sure it's reproducible. So first step of any project that any student join is I ask them to reproduce things. Yeah. And then in terms of presenting the results, you can present your ML flops and maybe like the size either of your model or size of your data. And you can present. So you can see it's sort of like this is probably where the cache runs out. So this is like, they try to show four different metrics. So you want to say what machine was it? So here's the machine. What kind of cache? What kind of size? And this can all go into your paper. It usually ends up in the appendix, but it can all go in there. Operating system, version facts. Has anyone here taken compiler before? No one taken compiler? Okay, so if you've taken compiler, you would know this. And then explain the timing method and then plot, right? Like make sure it's readable plots and things like that. Okay, so that's a little bit about benchmarking. It's only useful for people like, I guess Miriam should have been here, but for people who are doing like intense, like neural architecture stuff, that's going to end up in like the top neural and machine learning conferences. But it's good skills to have. And if you want to get on one of those projects, it'll be really cool. All right. So introduction to different types of figures, graphs, and tables. So I've told you how to write the results. I told you how to measure runtime. Now I'm going to tell you when you read a paper, how do you look at graphs? So yeah, so you want to take a look at what is the most important research question. Plot as many graphs as you want for fun. Like I tell all my students to do that. But when it comes to picking the right graph, you want to pick the one that answers your question. Make sure that, it makes your data readable and understandable. And the caption is standalone, right? Like you can just take that table figure or graph out, and I can just look at it and understand what it means. Of course, it needs to appear in the text, so I will always complain to you about that. Because what happens when a reader reads a paper, what they do is they will skim the abstract, look at the title. So the title has to be super interesting. So maybe like 10,000 people will see your title. Then they'll skim the abstract. So maybe like 1,000 people, right? 1/10 of the people will look at your abstract. So it better read really well and easy. Then then I usually flip through the figures, right? And that is why, like, your graphs, your figures, they need to be perfect. And this is terrible, but even reviewers, that's how they get a first impression of your paper. So I always say, in interviews, people make a judgment about you within the first 30 seconds. Same thing with the paper. People will judge a paper within the first 30 seconds by looking at the title, the abstract, and the figures. So you make sure your figures can highlight your key findings, and the caption really is like get your point across. And then you have very informative titles in your subheadings as well in the text as well as in your figures. So it has to be the main point of your argument. Okay. So the figures need to stand alone, and you need to explain the context. So like the meaning of the results and why, right? Like why is it important and what does it mean? So like interpret those results. And you need to decide, whether you're going to do a table, a figure, or keep it in the text. And that's up to you. You can try all three. when you first start out and see what makes the most sense. And in the final paper, usually you just need like 5 or 6 tables. If you have 1 or 2, that's too few for a long paper. So take heed, En-Shiun and Vivian. En-Shiun, yours is a 6-page paper, so you don't have to be as many as 5 or 6. Vivian, it depends on if you're submitting a 8-page or a 4-page paper. A 4-page, you can get away with half the results. Obviously, we don't want like, 12 or 13 results. In terms of figure, I would like every single paper to have a process diagram. This is like a database. I don't know, all these figures will be great for somebody else. But, if you watch, the Big Bang Theory, this is the friendship algorithm, right? So they have like the friendship algorithm. But I also said in the introduction that there's some figures that are really beautiful and it really makes a difference. So let me see if I can find it. Yeah, so this is the lemma figure that I always really like. Or, and then this is a more theoretical figure that has variables and then it goes with the equations and the machine learning equations in the methodology. So, this is like more theoretical. This is more pretty. But making first figure is really an art that not everybody might be good at. Okay. So deciding so sometimes you might have to get other people to help you make the figure or get other teammates to help support you. Okay, so deciding whether graphs or tables. So you can do a graph or you can do a table. So you do graphs when you have trends or relationships, or that's more important, right? Like you have hidden trends or relationships you want to show, like there's a linear trend or something. You use a table when you want the precise numbers, you're comparing groups or, data is not enough to produce a graph. Okay, so I guess we're gonna do a little activity now. Or should we do this one? No, let's just do graphs first. Okay, so here is some data statistics. So these are, I think, by languages, a few different, all the data, we did like 9 data sets and different languages and sort of different token counts and prop counts for these 9 different data sets. If you do line graphs, so take heed, Vivian and En-Shiun, like graphs are very important for your final report. You can have line graphs, scatter plots, make sure you do line of best fit, whether positive relationship, negative relationship, exponential, more linear, null hypothesis, all these different ones. Right here. Love scatter plots. These are good to have. In research, we don't love bar graphs and pie charts. So stay away from those. I think HCI is okay, the notion, so you can do that for yours. But definitely in machine learning, like these are not happening. But also in work, people really like these as well. Box plots, you just want to do, like here is instead of just like a dot or an average or a bar. So instead of a bar graph, never do a bar graph. Always go with a box plot or a violin plot, or there's other variations of this that I really like as well. But yeah, there's other variations of bar and violin graph plots I really like. But they really show like a distribution, right? Which is important because the bar doesn't show me anything other than a number. But a distribution shows me outliers, upper limit if there's a skew. Like you can see like this, I think this one is a slight double distribution. These two has a little hump. And then this one really skews to the bottom numbers. This one skews to the top numbers. It makes a huge difference. Popular in my field now is these spider, like these spider web, these web plots. I really like them a lot. So give them a try. En-Shiun, I think you can try these. Because I think your numbers are more simple. So you can try these and these. Heat maps are always great. You can have like very complicated heat maps. If you're working with languages, Vivian, you can do like a geographical heat map, like up here. For heat maps, you can also measure multiple dimensions. So you can have color as well as size. This one's just color with like a dendrogram. This one is not a heat map, but you can see like, instead of like boring scatter plots, like instead of boring scatter plots like this, there also these numbers, also these dots also have color and size, right? Two more dimensions, instead of just measuring X and Y, it also measures Z and I don't know, W, right? Z might be color and W might be, size. There's also these different type of more traditional heat maps as well. So, I love heat maps, so make sure you do them. Yeah, so here's an infographic guide of all the different types of graphs you can have. Obviously, companies like this, these ones, in research, we really like, these ones, heat map, spider graph, bar plots. So I just want to give you an example. This was a HCI study some students did for their 4 months project. And these are all the graphs they generated for 1 4-month project, right? They have these, slider bars. They have these. So to En-Shiun, these are maybe the graphs that you can look at. The En-Shiun.
Oh yeah. Okay.
Yes.
I can definitely look into these guys.
Yeah. So for HCI studies, like you have, these are heat maps, you have bar plots, you have sliding bars, and also like, and then also like, they also did these like scatter plots with different colors. Very important to have these. To En-Shiun, you can ask for these graphs from Robert, who is at Sakai right now. Or either Robert or who's the other person? Or
Okay.
Julie. Julie.
Oh, okay.
Yeah, Robert or Julie. Robert's Chinese name is Yi He. And then this is like a more machine learning type of a project. So you can see like, they showed the results. Usually I like to see standard deviations as well. So this one here has all the languages and the different layers, and then you can see the standard deviations. I love this one. This one Jose did, and it has like, the different heat maps. Although I keep telling him not to use green because there's a lot of, like a large percentage of the population is colorblind. So never use green, use blue and orange. So this one here does, so this is a few of these are the Uriel papers, Vivian, from York and Adia. So you can see that, we show, how much it increased by, decreased by, standard deviation, and then we bold so you can see that there's a legend. And in the legend, we bold the best one. And then we also, sometimes you might underline the second best one or underline the worst one or something. This one here, again, a nice bar plot, although this one also, has the standard. I like the standard deviation. And you can also see like in here, they also have the citations to the baseline papers they compare against. See, they compare against these days. And then this one is land rank. And so they have, the nice violin plots. You don't need to show, it's redundant to show violin plots from both sides. So they just went ahead and showed like one side of a violin, which is fine. Yeah. There's specific table formatting. So I said, when you're writing your report in Word, don't worry so much about it. But Vivian, the En-Shiun, and Joyce, you should start, once you finish writing in, Google Doc, and you feel like you got all the comments fixed and stuff, you can start putting it into LaTeX, because LaTeX is in the right graph table and graph formats, and so that's what you need to focus on, getting it correct. Okay, so we don't have much time left, so we're just gonna, I guess, play this little game here, and then your report should be almost ready to go. Okay, so what is wrong with this graph, Dylan?
Okay, so in terms of this graph here, I would say the biggest issue is the use of color. The fact that the main color in the background is a sort of medium gray, And then different variations of gray, not even white or black, are used for the rest of the conveyance of the data with the lines that are going across. It's very hard to read. It's hard to comprehend. It's not very professional looking. Yeah.
Very nice. Thank you. Yeah. Also, like, this is wrong, right? Like, you want to like maybe like put it in K or a different like. And what is this? Is it milliseconds, seconds? I don't know. What is this title? What is P? Right? Like, just tell me. And generally, this is not the right format for graphs for publication, right? Like these, you saw examples before. These are the right formats. I think people created these with like Microsoft. Anyway, back in the good old Microsoft days. What's wrong with this one, Joyce?
Again, it's grayscale and
Mhm.
it's kind of slanted. Or is that supposed to be how it's used?
Great.
Or
Also,
do you
like,
mean the numbers?
yeah, and the numbers are a little weird too. And like the fact that they're compared like this, I don't think this is a best bar plot is the best idea. Yeah, yeah. Okay. Yeah. Okay. Okay. Uh, okay. Why did we go from this one to this one? The answer's right there, but try to logicalize it. Can you tell me more? Oh, sorry. I need to pick someone. Sorry. Vivian. Vivian, is it okay if I call you Vivian, or would you prefer I use your Chinese name?
Both of them works. I think for this graph, they use different colors to differentiate for each data, and they have good use of the scale, like logarithm. So
Mhm. Okay. Great. Anything else? Okay, so that's good. And then lastly, this one. En-Shiun. Oh, sorry. So for this one, yeah, so everything's clustered in here. It's like too hard to see. But instead of using, instead of using like the real numbers, we put it on a log scale over here, right? 0, 100, 1,000, right? This is like 0, 100, 1,000. Oh, it's all cramped down there. So it's spread it out. If you do machine learning, how many people here know the scaling law? So scaling law is measured in log scale. Okay, En-Shiun, last one.
Um, I can't really see them all well. So I'm not too sure what exactly this is looking at. Are we just looking? I feel like this is too much. If the entire thing is what we're considering, it's like a bit too many graphs. I think there shouldn't be too many plot lines together, I guess. I'm not too sure
Okay.
exactly what I'm supposed to be pointing out here. It's a bit
Mhm.
unclear.
Yeah. Okay, great. Okay, all done. Oh yeah, and then tables, like I said, tables will become clear to you once you move things to LaTeX. Don't spend time playing with it in Microsoft Word or Google Doc. Like just LaTeX is gonna be, how many here has never used LaTeX before? Okay, good. LaTeX is gonna be, more. Okay, so there's more on tables there, but generally tables just like, it's just use the LaTeX. Some interesting things about the results. I guess we can go over this next time. Yeah, sorry, I had changed things around on how I taught it. When I used to teach this from the master's program, I used to teach it differently. So forgive me. And we will do this exercise next week. Okay, thank